All right, y'all. So the first two on the test, you got to know this chart right here. So we made this chart back in the first section we covered for test 3. So I'm going to look at the polynomials and the degree. I'm going to see if they're even or odd. And then I'm going to look at the lead coefficient to see if it's positive or negative. And I'm going to choose one of these 4 graphs based on this chart, okay? So let me share my screen for Math Lab and show you the first 2 test questions. I also notice they're giving me use an end behavior diagram to describe the end behavior of the given function. So we got to look at the degree of the polynomial, which is the highest exponent. And the highest exponent is 6, which is an even number. And then I got to look at the lead coefficient, which is that negative pi. And what we're interested in on that negative pi is a negative lead coefficient. So I got an even degree and a negative lead coefficient. Would y'all choose A, B, C, or D? All right, y'all. So let me share my chart again. Remember, it's an even degree. Even degree is one of the first 2 in the first column, but it's got a negative lead coefficient. So it looks like both ends should go down. So we would choose A on that one, okay? All right, next. Same question. The only difference on this one, they got it out of order. The degree is the 7. The lead coefficient is the 0.4, since that's the number in front of that variable. So 7 is an odd number. 0.4 is a positive lead coefficient. So when it's odd with a positive lead coefficient, that one is going to be the picture where it goes uphill, left to right.
See.
Okay, y'all. So the first 2, like I said, you're just looking at that chart. Okay. Even, odd degrees, positive lead coefficients, negative lead coefficients. Okay, so then on number 3, they want you to find the zeros. So find the zeros and the multiplicity. So they're giving us f of x equals x squared minus 16 to the 5th power. Now, right off the bat, that exponent 5 is the multiplicity. So that's going to be the multiplicity of whatever zeros I can get out of this equation in this factor. So to get the actual zeros, we're going to set x squared minus 16 equal to 0 and solve that for the x's. And y'all, this one, the easiest thing to do would be to add our 16 to both sides. Get x squared equals 16, and then do our square roots to it. So that'll be a plus or minus square root of 16. And y'all, x equals a plus or minus, and the square root of 16 would be 4. So on this one, your answer would be plus or minus 4, because that's my zeros. And then each has a multiplicity of 5. Because remember, that 5 tells me that this would technically be x squared minus 16 times itself 5 times, okay? So the outside exponent multiplicity, solve the factor inside the parentheses for the actual zeros. All right, so number 4 is doing the same thing. So this one has the f of x equals negative 8 times x minus 4 to the third, x plus 1 squared, and then an x to the fourth. So this one's factored out already. So all the variables with the x are where I'm going to get my zeros. So y'all, this one wants me to find the zeros and the multiplicity again, okay? We're not worried about the negative 8. Whatever number's in the front, we don't care about. It does not have a variable. What we're going to do is set all 3 of these equal to 0. X minus 4, x plus 1, and then this x equals 0. So the single variable, no matter what that exponent is, it's always going to equal 0, okay? Now these exponents here are all the multiplicities. Okay, so the outside exponents are our multiplicities. So we'll solve these 3 and get our zeros, which that one's already done. So y'all here, let's move the 4 by adding. The second one, I'll subtract 1. And then the third one, I've already solved. So this one will say the 0, 4 has multiplicity blank. Blank is a 0 of multiplicity 2. And then the remaining 0 is blank. It has multiplicity blank. So y'all, answer this first one. The 0, 4 has a multiplicity of what?
3.
3. Good job, because it came from that factor. All right, so what about this one? Blank is a 0 of multiplicity 2.
Negative 1.
Negative 1.
So negative 1. And y'all, the remaining 0 is blank, and it has a multiplicity blank.
1.
Oh, no, now where y'all getting the 1 at?
0.
0. Remember, that's my
4.
last one, 0. And it has a multiplicity of
4.
4.
There you go. And y'all, every time I've seen this question, the remaining 0 on them all was always 0, because they're going to give you this x at the end. They're just going to change its exponent probably. Okay? So y'all's questions are going to be very, very similar to mine. All right, so the first of the challenging problems is coming up on this number 5. And it also wants us to find zeros and their multiplicities. But y'all, this is the one where we had to learn to factor. We had the f of x equals x to the third minus 7x squared minus x plus 7. So this is the one where I showed y'all the grouping. I group the first two terms together, and then I group those last two terms together. And we're going to factor out a greatest common factor from each group. So the first question, the first two terms, I got an x to the third, 7x squared. What would y'all pull out of that as your greatest common factor?
X squared.
Okay, good job, x squared. And in the parentheses?
X minus 7.
Okay. Now remember, the second GCF has to be negative like the third number here. The third term is negative. So the second GCF is negative. So what would be the greatest common factor between an X and a 7?
1.
1. So y'all, the second one, I'm pretty sure you're going to be factoring out a -1 just like I did. And all that's going to do is change the signs of those when I put them into parentheses. So the -x, factor out that -1 gives me an x. A +7 dividing by that -1 makes that a -7. So remember, your parentheses had to match up at this point. Okay, that's why you had to make sure to pull out a negative so that these parentheses match up exactly. All right, y'all. So at that point, I said y'all are going to put this stuff in these two parentheses. Do you remember what I would have put into two parentheses?
Yes, sir.
Okay.
Is it x squared minus 1
X squared minus 1.
and x minus 7?
X minus 7. Perfect. Now, we're factored. So let me ask you this. Since there's not an exponent outside of these parentheses, what would y'all put there? Because that's going to determine our multiplicity.
1.
Oh, what was that?
1.
1. So y'all make sure you treat those multiplicities on this one as a 1. And y'all's are going to be 1s just like mine. And y'all's are really going to be similar to this. So we've got it factored. We know our multiplicities are 1. So now we'll set both them factors equal to 0 so that we can find our zeros. Y'all want to learn that we set everything equal to 0 in this class, okay? So I'll get my first two zeros here, my other 0 here, because remember that exponent 3 right there tells me I got to get 3 zeros, okay? So here we go. We're going to add 1. X squared equals 1, and then we'll do our square root. So that'll be a plus or minus square root of 1. So y'all, radical cancels the exponent on the x, and that's just going to be a plus or minus. Well, y'all look at that. Square root of 1 is 1. For the last 0, I'm going to add my 7 and get x equals a positive 7. So this one you'll put, it'll say the zeros are x equals, and then it says each 0 has a multiplicity blank. So we set our zeros. Now you can use a plus or minus 1, or you can do 1, -1, and then 7. And then we said each 0 had a multiplicity of 1 on those. So y'all's is going to have a 1 for your multiplicity no matter what. The only difference is your 3 zeros, okay? But I'm pretty sure it's going to break down pretty much like mine did, okay? All right, so now I'm going to say, is this true or false? So number 6 is a true or false. If P of x equals x minus 9 squared times the x plus 5 to the third, then the graph, crosses the x-axis at 9, 0. So y'all, if you remember, I'll write a little chart over here. If it's an even degree, it's tangent. If it's an odd degree, it crosses over. So they're looking at this point, 9, 0. The only factor that would give me this x-interceptor 0 would be the x minus 9. And y'all look at that. It's got an exponent of 2, which is even. But they're saying it crosses over the x-axis. So since it really should be tangent, this one is false. And then you got to tell it why. So you got to find the one that says false and tell it why, because the exponent 2 is even. Thus it is tangent. Okay, so just look for the one that gives you the right reason on that, okay? So y'all write this little chart right here is all you need on that. You're looking at the multiplicity of which factor. Now this one, it would have been true if they'd had a negative 5, 0, because that had a 3 for the exponent, and that one would have crossed over, okay? All right, so number 7 here. For the function, determine the maximum number of real zeros x-intercepts and turning points. Now they're giving me f of x equals negative 3x minus x to the 4th. So we'll do maximum real zeros, maximum x-intercepts, and then our maximum turns. So the question is, do y'all remember what I did to this to find those numbers? Now I'll give you a clue. It depends on that degree, and this one's out of order. So remember, this is the degree 4. So we said that the maximum real zeros is equal to the degree. So since that's a degree 4, the maximum real zeros is a 4. We also learned that x-intercepts and zeros were basically the same thing. So if you got 4 real zeros, you got a maximum of 4 x-intercepts. So these two both equal the degree. But what about my maximum turns, y'all? What is my maximum turns for that polynomial? And that one ain't equal to the degree like the first two, okay?
Is it 3?
It is definitely 3. So maximum real zeros equals the degree. Maximum intercepts equals the degree. Maximum turns is the degree minus 1, okay? So let's write that here. Degree for that one. Degree for that one. And then degree minus 1 for that one, okay? All right, so let's see. Okay, so the next couple are going to be graphs. So I'm going to go back into MathLab and show us those. So let me share MathLab and go to number 8. And I want to show y'all how I'm actually going to get these pictures to look perfect. I'm going to graph this function in y equals, and I want y'all to notice my y goes from negative 100 to 100 on all these graphs, and my x's go from negative 10 to 10. So if I set my calculator window to match that, then I'll be able to pick the perfect graph, okay? So let me write this down so I can put this in y equals. And then do my window, okay? Because if you set your window right, you're going to get one of these 4 pictures exactly. So let's go to the calculator. So let's go to y equals, and I'm actually going to put in the function first. So I had an x times parentheses, x minus 5, parentheses, x plus 3, and then in parentheses, x minus 6. All right, so let's set the window. I'm going to hit window button. Now the x's went from negative 10 to a positive 10. And then I'm going to go down here to my y and go from negative 100 and a positive 100. All right, y'all. So when I graph this, we should be able to pick one of those 4 graphs. So here we go. So it basically almost looks like a W. Okay? And it's going up on both ends. So let's see if we can pick the graph. Well, this one looks like it's going uphill left to right. B looks like an M shape. But look at C. There's our W-shaped graph. I'm going to make that a little bigger so y'all can see that. So there's the one that looks like my graph. And then D, they got a whole bunch of lines on that one, but too many. So on that one, we would pick C and go to our next one. Now y'all look at this one. I'm going to graph this in y equals, but look at it. It has a different window. I'm going to set it from negative 5 to 5 and negative 250 to 50. I mean 250. Now, let me write this function down. 12x cubed minus 9x squared minus 108x plus 81. Now, we'll say this. That's an odd degree with a positive lead coefficient on this one. So it should be one of the ones that go uphill left to right. So it's either got to be B or C. So what we got to look at, is it crossing through the origin of the graph, or is it above it like the C has? So let's go graph that and then see which picture we come up with. So I'm going to go to y equals and clear this one out. Put in my 12x to the cube. All right, let me arrow back down. Minus 9x squared. Minus 108x. And then plus 81. Now remember, I'm going to set my window. Remember, this one went from negative 5 to 5. So negative 5 on the x to a positive 5 on the x. And then down here, my y went from negative 250 to a positive 250. All right, so when I hit graph, remember, based on the degree and the positive lead coefficient, it should go uphill left to right. And y'all, there you go. Now look, this is not crossing in the origin of that graph. It is up above it on that y-axis. So let's look at that and go pick our picture. So y'all, that looks like C to me. See how it's up above the origin where the x's and y cross? B has it going right through that. So we would pick C on that one and move on. All right, so the next one, I'm going to go back to doing it on my paper here. All right, y'all, so this would be number 10. So number 10, we start getting into more zero stuff on finding them. So here's our buddy synthetic division. It says using synthetic division, determine whether the numbers are zeros. Now, they're giving me -2 and 1. And then my function is h of x equals x to the 4th plus 2x to the 3rd plus 2x squared minus 4x minus 1. All right, so here's the thing. If I'm using synthetic division, y'all, and I'm going to check these two numbers to see if they're zeros, what does my remainder have to be if it's a zero? Uh-oh, so y'all remember, if it's a zero of that polynomial, when we're done, that remainder has to be 0, okay? So if it says 0 for my remainder, I'm going to put yes. Any other number, we're going to put no. So I'm going to check -2 first. So I'm going to write out my coefficients. Nothing's missing because there's my x4, x3, x squared, x, and my number. So let's write all the numbers down. 1 for the x4, 2 for the x3, 2 for the x squared, -4 for the x, and then -1. All right, so one of y'all remembers synthetic division. So what's the first thing I'm doing to this?
Bring the 1 down.
Okay, I'm going to bring the 1 down. So what are you going to do now?
Multiply the 1 times the -2.
So what's that, -2? All right, now what are you doing?
Subtract 2 from 2.
Ooh, we get a big 0 there.
Multiply that times -2.
So that's going to be 0.
Subtract 0, you get 2.
Okay.
Multiply that times the -2.
So that's what a -4, right? And let's see, -4,
-8.
uh-huh.
And then multiply that times -2, 16.
Uh-huh.
Subtract from 1 is -15.
Oh, positive. But that don't matter. We didn't get a 0 there, did we?
Nope.
So this means -2 is not a 0 of this. So let's check the 1. Now we use the same numbers. 1, 2, 2, -4, and -1. All right, I guess the same process, right? Bring my 1 down. I'm going to do the same thing you did here. Bring it down, multiply, and keep going, okay? 1 times 1 is 1. 2 plus 1 is 3. 3 times 1 is 3. 2 plus 3 is 5. 5 times 1 is 5. Oh, looking good now, because 5 and negative 4 is 1. 1 times 1 is 1. Y'all look at that remainder. That remainder is a big 0. So this one would be a yes. So they'll ask you, is negative 2 a 0? You put in your answer. Then they'll say, is 1 a 0? Then you put in your answer, okay? All right, let me see what y'all remember on this. Suppose a polynomial of degree 4 has the following as zeros. They say find the other zeros. Now what they're giving me as the zeros is a negative I, comma, 4 minus square root of 13. So here we go. The other zeros are blank. All right, y'all. They're giving me a degree 4. That's got 4 zeros. They're giving me 2 of them, a negative I and a 4 minus square root of 13. Question is, what's the other 2 zeros? And I want y'all to think about it. It's conjugate pair stuff, remember?
Positive I and positive
I.
square root of 13.
Oh, what was that one?
Is it positive square root of 13?
So 4 plus square root of 13. Remember that 4's got to be there too, okay? Because this is like one number there. So good job. Change the sign of your i's. Change the sign of your radicals, okay? Now, the reason you had to learn that was because of this next question. It says, find a polynomial of lowest degree with zeros of square root of 5 and 5i as sum of its zeros. So let's see. So this is where we did all that foiling. But y'all, we know this. If x equals a square root of 5, x also has to equal what?
Square root of -5.
Or, yeah. Throw that negative on outside. There you go. Now, if x equals 5i, then I know x has to equal what? So what's the conjugate of that 5i?
Negative 5i.
Negative 5i. There you go. So remember, they're going to give you 2, but you got to do their opposites as the other zeros. All right, so now I'm just going to practice on getting a 0, putting them in parentheses, and then doing my foiling, okay? So you want to subtract on this one. So x minus the square root of 5 equals 0. Add this one. X plus square root of 5 equals 0. Here I'll subtract 5i. X minus 5i equals 0. And then finally add 5i. And get x plus 5i equals 0. Now, when I put them in parentheses, I'm going to set this whole thing equal to 0. And then we're going to start foiling the first two together and the second two together. But remember, on these ones, we can definitely shortcut it because they're conjugate pairs, okay? So I'm going to shortcut foil these. And whatever I get out of each one, I'll put in my next set of parentheses. So foiling this one, shortcut method. X times x is x squared. A negative square root of 5 times a positive square root of 5 is a negative square root of 25. So the inside of the radical can multiply by the inside of the radical. Here, conjugate pairs, so I'm going to shortcut that. X times x is x squared. Negative 5i times 5i is a negative 25i squared. Now, finish simplifying those before we go on. Bring down that x squared. Minus, for y'all, the square root of 25 is 5. So a radical times itself equals that number that was under those radicals. Now over here, what did I say I squared equaled?
-1.
I squared equals -1. Good job. So that's really like negative 25 times -1. That's going to make that an x squared plus 25. Y'all, the radicals always end up being subtracted. Imaginary numbers always end up being added. All right, now this, I'm going to FOIL. Now here's the thing. These are not conjugate pairs like these were up here. So we got to FOIL everything out on this one, okay? So we got to do the x squared times x squared is an x to the 4th. X squared times 25 is a 25x squared. Negative 5 times x squared is a negative 5x squared. And finally, that negative 5 times 25 is a negative 125. Can I go further with that? Oh, y'all are so quiet today. But y'all, we got like terms in the middle. So bring down that x4. 25 minus 5 leaves me 20x squareds. And then minus my 125. So let's see, all MATLAB is going to want, they're going to have f of x here. All you do is put in your polynomial. Okay? So don't forget to add y'all's like terms together either, because this type of problem right here always has x squareds that are like terms in the middle, okay? All right, so y'all's going to be similar. Y'all might get square root of 3s, square root of 2, and, you know, they're just going to change the numbers is all, okay? All right, now notice I got an exponent 4 here because I had 4 zeros, okay? But they're not giving you that as in the beginning because they don't want to give away that they got to be the conjugates, okay? All right, y'all. Then 13 was back to finding zeros. So the polynomial has the given 0. They want us to find the other zeros. So let's see what I got. My polynomial is f of x equals x to the 3rd plus 5x squared minus 3x minus 15, and they want me to, the zero they're giving me is a -5. So this problem is the one where I had to use synthetic division and divide out that -5. And when I'm done, I'm going to use those three numbers that are in the quotient to find the other two zeros, okay? All right, so let's see. X3, x squared, x, and number. Nothing's missing, so we got a 1, 5, -3, and -15. Now, here's the thing. Since they told me -5 was a zero, I got to get a zero remainder. Now, these three numbers that we get right here, we're going to use some kind of quadratic method and solve those, okay? So let's divide this out and see what we get. So bring down to 1. 1 times -5 is -5. 5 minus 5 is 0. 0 times -5 is 0. So bring down that -3. -3 times -5 is 15, which gives me a 0 remainder. So remember, these are the numbers of the new polynomial 1 degree less than that 3. So that means this would be 1x squared plus 0x's minus 3. Now we set this part equal to 0, and we're going to solve it. So notice, to solve this, I'm going to add 3 to both sides. I get x squared equals a positive 3. Then I'm going to do the square root. So that's going to be a plus or minus square root of 3. So y'all, the radical exponent cancels, leaving the x. This will be a plus or minus. Well, y'all look at that. I can't take the square root of 3, so that's going to stay square root of 3. Now, this one will say the other zeros are blank. We don't put in the -5 that they gave us. We're only going to put in the 2 that we solved for, okay? Now you can use the plus or minus, or you can do square root of 3, comma, negative square root of 3. So I'm pretty sure y'all's last two zeros are going to be done just like mine. You should get a 0 in the middle. So that's going to make it to where it's really quick if you do the square root stuff. Now, 14 is just like 13, but guess what? They're not giving me my first 0. So this one, they want us to find the rational zeros. Then the other zeros. And then factor into linear factors. Now I'm going to show you a trick on this one, okay? So they're giving me this. F of x equals 3x to the third plus 7x squared plus 147x plus 343. Now, here's the thing. Since they didn't give me a 0, I'm going to graph this and find my first 0 by graphing. Now, let me show you some tricks on this, and so watch what I'm about to do. So I'm going to first go graph it. Now, I'm going to set my window back to normal, 10 by 10. So to do that, you hit the zoom and number 6. That puts it back on a 10 by 10. So let's go to y equals and punch in our function now. So I had 3x to the third plus 7x squared plus 147x plus 343. Now, y'all, want y'all to see something when I graph this. Look here. That line is crossing between -2 and -3. So since it's not on the actual number, let's go to the table and I'll show you. Between -2 and -3, I don't have a y value of 0 there. Remember, if it's a 0, it's got to have a y value of 0. So based on that, I can't tell. So let me show you a trick. Since the first number on my polynomial was a 3 in front of that 3x to the third, watch what I do. You see above the window, it says table set. So you're going to hit second window for the table. And I'm going to come down here where you see the triangle table. That means how much do I want my table to change? Well, since I got a 3 in front of my x third, I would make this a 1/3. So that I can change it by thirds. If you have a 2x to the third, you're going to change it by 1/2. 5x to the third, you would change it by 1/5. Now remember, now watch my table, because it's going to split it into thirds. Whoops, let me go to second table. Now, look in between that -2 and -3. Now, I have a y value of 0 at that point, -2.33333333. That 3 goes on forever. Now, write that down. That's a -2.333, because I'm about to turn that into a fraction on my calculator to see what it gives me. So you're going to get a fraction on that one, okay? So look for the one that had the y value of 0. Now I'm going to quit that screen, and I'm going to do -2.3333, and I'm just going to run that 3 for a while. And then I'm going to hit enter. Whoops, I'm going to hit math. I'm going to hit my math button and turn that into a fraction by hitting enter. So look at that. It gives me a -7/3. That is my first 0 I got to try. Now, in a little bit, I'll show you how to set that thing back, okay? So we got to use this -7/3 as our first 0. And that is a rational 0 because it's a fraction. Anything that you get that's like a whole number, integer, or fraction, they're all rational. If we get imaginary or square root stuff, that'll be the other zeros. All right, y'all, let's see. Nothing's missing. So we got our 3, 7, 147, and 343. Now, since we only got an x to the third, we're only going to have 3 zeros. Well, this is one of them. These 3 numbers we'll do just like we did up here and get the last 2 of those zeros, okay? All right, so y'all, this ain't as bad as it looks. Bring that 3 down. -7/3 times 3. So -7/3 times 3. Well, y'all, the 3's cancel. That leaves me a -7. 7 and -7 give me 0. 0 times -7/3 is 0. 147 plus 0 is 147. So now we got 147 times a -7/3. Well, y'all check this out. This 147 will divide by 3 and give me 49. And guess what? -7 times 49 is a -343. But y'all remember, Calculator, punch in -7/3 times 147. It'll give you -343, which we knew we had to get a 0 here anyway. Okay, because that's where that thing crossed over that x-axis at. So now we got to use these three numbers to get the last two zeros. So that started as an x3rd, 1 degree less, means that's a 3x squared, plus 0 x's, plus 147. So I'm going to set that equal to 0 on this one. I'm going to move the 147 over, because I'm about to do the square roots to this. So subtract the 147. I get 3x squared equals -147. I'm going to divide by 3 before I do the square root, because you always want that x squared to be over there by itself, okay? So that cancels. We got x squared. Well, -147 divided by 3 gives you a -49. All right, so now we can do the square root. So this will be a plus or minus square root of -49. Well, y'all, that's going to give me my x. This will be a plus or minus. Well, what is the square root of a -49, y'all?
Seven.
Oh, 7's close.
That's 7i.
Yeah, because remember, that's negative under there. So that's going to give you a positive or minus 7i. So it'll say rational zeros. Your rational zero is the -7/3. So on this one, I would check the one that said there is only one rational zero, which is -7/3. The other zeros are, well, all my other zeros were the plus and minus 7i. So 7i and -7i. Now, the linear factors, that's a little bit tricky on this one. They're going to have a blank here where the linear factors. Remember, that's putting all of these in parentheses. So I got 3 zeros. I'll have 3 parentheses. Now, y'all, here's how you have to do the first one. This one will be x plus, change the sign on the 7, make that a +7. Now, they don't like them in here as fractions. So the 3 on the bottom, you have to bring out to the front of your parentheses. Okay? Change the sign of the top number, bring the bottom of the fraction out front. Now, 7i, change the sign, make that a -7i. And then the -7i, change that sign and make that a +7i. Now, if you mess up a little bit on this one on the review or test, I will override that because I don't like how MathLab does the 3 out front. I would probably put it in front of my X, but since MathLab is doing it like this, if you get the 3 zeros, but you mess up on this, let me know and I'll fix that on your quizzes, okay? Now, y'all, that's to me is one of the trickier ones because you got to remember to set that table based on that first number. 1/3, 1/2, whatever, okay? All right, y'all, so that puts us on 15. We start doing domains. So 15 says, find a domain. Now they're giving me f of x equals x to the 3rd minus x squared plus x plus 1. We also domain, so we don't really care what's on top. What we care about is the x squared plus 7x plus 6. Now I got to write this in both set builder and interval notation. So to find my domain, I got to find any numbers that make it undefined. And to do that, I'm going to set the bottom equal to 0. I'm going to factor that now. So you're going to have to factor yours. So y'all, what does the x squared plus 7x plus 6, what does that factor into?
X plus 1 times X plus 6.
There you go. Factors of 6 that add to get 7 are 6 and 1. Good job. They're both positive because the last one was positive. Both of these are positive like the middle. All right, y'all, so good job. And we'll just set these equal to 0 and solve them. So both of these will actually become negative now. So set builder, you're going to choose the one that has x such that x is a real number. And x cannot equal blank. And x cannot equal blank. Now, here's the thing. This has to be in ascending order. The smaller number got to go first, and the larger number goes second. Well, -6 is smaller than -1, so you got to put the -6 first, and then the -1. And I really think they're doing that because of the interval notation. They got to be in order. So interval notation would start at -infinity until we hit -6. Union around -6 till we get to -1. Union around that -1 till we get to infinity. So your number 15 will have two numbers, but make sure you put them in the right order on both answers, okay? All righty, 16 was find the domain. This one was like from 5-1, and this one was from the what was it? 7-5 section. So this one has, and now this one I've only got to write it in interval notation, okay? So f of x equals 2 over x squared plus 3x minus 28. So same thing. I'm going to set the bottom equal to 0. We're going to factor this. So y'all, the x squared is an x and an x. So let's see if y'all can factor that. What numbers go in here with what sign? Now remember, what I'm really looking for on this one are any factors of 28.
7 and 4.
7 and 4, so that's my numbers. So who's positive, who's negative? So remember,
The 7 is positive, the 4 is negative.
There you go. The larger factor has to be positive like the middle. There you go. And the other factor will be negative. All right, good job. So now let's just set them equal to 0. So now subtract 7. Here with what? Add 4. So my interval notation, so -7 comes first. So from -infinity to -7, union -7 to our +4, union from 4 to +infinity. All right, now let's see. 17, list the asymptotes. Then graph. So let me see what MathLab pulls up for us on 17 here, okay? Because I want to do the one-day guide so that we can look at their graphs. So let me share MathLab so we can get our question. And this I said was what, 17? So they're giving us f of or r of x equals 3 over x squared minus 25. So notice what it's wanting. Vertical asymptotes. Now remember, oblique, you got to put no oblique asymptote for that one. So basically, we got to find vertical and horizontal, and then we'll look at the picture. So let me go to my pad. So we're looking at vertical, horizontal, and then we'll graph it. Oh, let me look on the graph. Well, we'll do them as we go, and then we'll look at what the window was on our graph, okay? So vertical asymptote is first. Well, to find vertical asymptote, I took the bottom, set it equal to 0. Because vertical asymptotes pretty much equal what the numbers we're excluding from the domain are. So y'all, the easiest way on this, add 25 and do square roots. So x squared equals 25. Then I'll do my square root of that 25 so that x equals a plus or minus 5. So first of all, let me show you how you got to put that in, because they got to look like an equation. So did they put the... Oh my God, y'all. Let me get back in here again. Oh, and I bet it's going to change my problem. All right, so let me get back to the test 3 review. And go back to 17. I guarantee you they probably switched it on me. All right, so now I gotta 7 over x squared minus 4. So r of x equals 7 over x squared minus 4. All right, so let me do that since that messed me up. All right, so vertical asymptote once again, but look how similar they are. X squared minus 4, set that equal to 0, add 4 to both sides. X squared equals 4, and then do our square roots. So y'all, that cancels. X will equal a plus or minus 2. All right, let's see if it'll let me go back and put that in. Now, it says type an equation. So we got to do x equals, x equals 2 comma x equals -2. Now you can use the plus or minus. I think you have to hit the more down there. But you got to punch the x equals, okay? Now remember, there's no oblique asymptote for B. So all we got to do is find our horizontal asymptote. So the horizontal asymptote depended on the degree. Well, y'all, the top is a degree 0 because there's no variable there. The bottom is a degree 2. Because that's the highest exponent on the bottom. So the bottom degree is greater than the top degree. Do y'all remember the horizontal asymptote when the bottom was higher degree than the top? That's angle equal y equals what?
0.
0, perfect. And this one has to be put in like an equation. So I would go back. See, it says type an equation right by it. So we would do y equals 0. Now let's look at the graphs. So look at this. They're going from -7 to 7 on the y and -4 to 4 on the x's. So I'm going to go graph that now. So let's see. -4 to 4 and -7 to 7. So we're going to look for one of these 4 pictures. But y'all, we know we got vertical asymptotes at 2 and -2. So it's either got to be A or C because they both got the asymptotes, okay? All right, so I'm going to go calculator. Now remember, my table, I'm going to go back to table set. And I'm going to go down here where that delta is and put a 1 back there. Okay. Now I'm going to go to y equals. Now, to make it look like a fraction, I'm going to hit alpha y equals, enter. That way I can put my 7 on top, arrow down, and put in my x squared minus 4. Now, go to window. The x's went from -4 to 4. Go down to the y min, and those went from -7 to 7. Now, when I hit graph, I should get one of those 4 pictures. So look, the middle, my U shape is upside down. So look at these 4 graphs. And y'all, C was going uphill. We needed A because ours was upside down on the U and in both the sides, okay? So click A, and then we can move on. All right, so let me go back. The next one I'll do by hand. So this one will be 18. Determine the horizontal asymptote. And I got f of x equals x squared minus 4 over 5x to the 4th plus 4. So same thing again. I'm looking at the degrees and seeing where it's bigger at. So y'all, what's the top degree? And what is the bottom degree? So y'all, what y'all think on top? What's my degree?
2.
All right, 2 there. Bottom?
4.
Perfect. And look at that. Bottom's greater than the top. So what's my horizontal asymptote? Oh, y'all, look, we just
Is
had
it
one.
y equals 0?
Y equals 0. Good job. Okay. So, yeah, both of these had the same horizontals because they were both bottom heavy. If it's top heavy, if the top's greater than the bottom, that's the case where you had no horizontal asymptote. And if they were equal, that's where we looked at the numbers in front, okay? All right, y'all, this one is what we did last class. Solve the inequality. And it's already factored. X minus 2 times x plus 3 less than 0. So it's already factored. All we got to do is set these factors equal to 0. and solve these. I'm going to add 2. I get x equals 2. Here we subtracted 3 and get x equals a -3. And y'all remember, at that point, I made a number line with these two numbers. So let's see, -3 would be first, and then your 2. Now, I don't know what number y'all tested, but I always test my 0. And that 0 is in between these two numbers somewhere. So I know I'm going to test me a 0, okay? So put a 0 in for both these x's. You get 0 minus 2 times 0 plus 3 has to be less than 0. So y'all, let's see what that gives me. -2 times 3 less than 0. -6 less than 0. True or false?
True.
It is definitely true. So remember, if it's true where 0 was, you're going to shade that in between those numbers, okay? So my interval will go from -3 to 2. But here's my question. Am I going to put parentheses around these numbers, or will I use brackets around the numbers?
Parentheses.
All right, good job. Parentheses. And -3 to 2, close parentheses. So remember, when your interval is in between the two numbers, that's all you have on your interval notation, because that's the only part that made it true, okay? Oh, y'all look at that. We're on number 20. So our last one. And it's going to be another one of these inequalities, okay?
Sir, could you go back to the other one real quick so I could get the last part of it?
So my number 19.
Yes, sir. Sorry.
Oh, that's no problem. And y'all's are going to work the same way. It's already going to be factored. You're going to get two numbers on here, and then you're just going to test whatever number y'all want to test. But I'm hoping y'all see how easy them zeros are for me, okay?
Yes, sir. And I got it, by the way. Thank you.
Okay, no problem. All right, y'all. So the last one to solve. X squared plus 8 is less than 2x. Well, we need a 0 over here. So that means we got to move that 2x by subtracting it on both sides. So let's see, that'll give me what, an x squared minus 2x plus my 8. That'll be less than 0. So now we're going to try to factor that. And when I factor it, I'll set it equal to 0. So I got an x and an x. So y'all, what two numbers go in here? Factors of 8, that'll equal 2. And remember, they got to add to get me a 2, okay? And I guess we don't got
There isn't.
Yeah, because we only got 2 guesses. 1 and 8, that don't work. And what? Oh, 2 and 4. That adds to get 9. That adds to get 6. So you said there ain't none, right? Because there's no way these would both be negative, but there's no factors of 8 that add to get 2. So this one does not factor. Good job. So since it didn't factor, what did I put as my answer? Well, think about it. I don't have any solutions. So what did I use in my, so it does not factor, therefore it's no solution.
Is it the 0 with the line in?
It is the 0 with the line. You got to use this in math lab, okay? Use that symbol right there. We call that the empty set or no solution, okay? So that means if you was to actually solve this on the quadratic formula, you'd probably get imaginary answers on it. And we don't care about imaginary answers. We want to solve these in the real world. So anytime you can't factor that, and I'll show you if you was to graph this. Let me show you. If you was to graph it, you would see that it's so let me punch that in here and I'll show you something here. I'm gonna clear that out. So that was what, an x squared minus 2x plus 8. Because remember, the solutions are where they're crossing the x-axis. Oh, I need to zoom back normal, remember, because I had my window set a while ago. So I want it back on a 10 by 10. You see, it don't even cross the x-axis. So that means that that little graph has imaginary zeros. So we're good at, there's no solution in the real world for us. Because actually, the whole graph is greater than 0. There's nothing less than 0 because there's nothing under that x-axis, okay? Alrighty, so let me see. Oh, that was number 20, right? So, y'all got questions on that? Y'all work these just like we did on this study guide. And if you didn't get notes during the lecture, watch the video, get your notes, because your test is in the same order, same type questions. You'll probably get a lot of the same answers I got on mine. Every time I done number 20, it was always usually a no solution. So it might possibly factor, but I doubt it for that number 20. And the trick is just getting good on that calculator, changing them windows when you need to, changing the table when we need to, and it'll knock out all these harder type graphs, okay? Now, let me go back and share my thing one more time because I got to show you the ones I won't work on. And I'll send this in the email, but I need work shown on 3, 5, 10, and 12. So only 4 of them, okay?
Is that the test or is that the review?
Oh, only test only.
Okay. Now, are the reviews, are those actually quizzes? Or are they just reviews? Are we being graded off the reviews too?
Oh, yeah, whoops. The review counts towards your homework and quiz grade.
Okay.
So yeah, the review is basically the only quizzes you're getting every time, okay? Now, watch out for this. I'm going to send a bonus for test 3 in my email later. So you'll get my video for test 3 review, and you'll see what I'm going to do for the bonus for test 3, okay?
So are you gonna write it in there, or do we watch the video over and you're gonna say it at the end?
Oh no, I'm just going to write it in the email. And I'll say like, for bonus, solve this problem or something.
Okay.
Okay.
And would you mind going back to problems 8 and 9 real quick so I can grab a picture?
Let me see. 8 and 9.
Yes, sir.
Okay. Now, basically, though, on 8 and 9, I just graphed them and seen what they look like.
Okay, yeah, I think I remember you doing that part.
And I just had to set my window based on the graphs. Remember, negative 10, 10 was my x's, negative 100 and 100.
Yes,
So this
sir.
was my x min, x max, y min, and y max. And then I
Yes,
did
sir.
that on number 9 also because their window was different looking at their graphs. So x min, x max, y min, y max.
So what was your answer for them?
Well, that was on let me pull that up.
Oh wait, that you got the answer from graphing it. Okay, I think I remember now.
And then remember we picked out one of these. Whoops, let me go back. Where did my 8 go? Yeah, we picked out one of these, and I think mine looked like the W on that one.
Yes, sir, it did.
And then number 9, remember that one for me was the one that went above the right here. See how this first one is not
Yes,
rolling
sir.
right center? So that one was A for me.
Okay. Thank you
Okay.
very much.
All right, no problem. So y'all do that study guide before you try that test. I've been having people knock out the test before they did the study guide, and they ain't been so happy, okay? So do the review, because you're basically doing the test when you do the review, okay? Knock that out, then knock out your test. That way, if you got any questions on that review, y'all can email me and I can try to fix you.